Hello, in this video we're going to look at series and parallel circuits. So there are two ways of joining electrical components together, and they are in series or parallel. If we look at series first, what we've got is a source of power, so a cell. A current can then flow round through a resistor and go all the way back. There's just one loop. This is another example of a series circuit. We've got an additional resistor, but there's still very much one loop, one path for the current to flow round. Series circuit. The key thing to know about this is it's the same current through each component, and ammeters are also placed in series in the circuit within the same loop. So at all points the current is the same. So no matter where we place the ammeter, as long as it's in the same loop, the value on it will always read the same number. In lessons, your teacher may have shown you the rope model, where everyone stands round in a circle holding a piece of rope, and the rope, as you pass it through your hands, goes round at the same rate. The charge moving flows the same through each component at the same speed. The current is the same. However, when we're measuring the potential difference using a voltmeter, that gets placed in parallel across what you're measuring. And the total potential difference of the power supply is then shared between the components that are in the circuit. So if we take this as an example, we've got 12 volts across our cell, or it could be a battery, or it could be a power pack. We've got 9 volts across this resistor and 3 volts across this resistor. It might be shared equally, but in this case it isn't, because it depends on the resistance of the resistor or the component. But either way, 9 plus 3 gives us the 12 that we started with. If we look at the resistances of the two components, the total resistance of our two resistors in series is the sum of the resistance of each component. That then leads to this equation. The total resistance equals R1 plus R2. And as a reminder, resistance is always measured in ohms or with the Greek letter omega. So if we look at an example here, resistor 1 or R1 has a value of 10 ohms, R2 or resistor 2 has a value of 20 ohms. So we can calculate the total resistance, R total, by adding the two values together, 10 plus 20, which of course gives us 30 ohms. So when in series, resistance always increases, so the number always gets bigger because they add together. The other way of combining a circuit is in parallel, and here's an example of a parallel circuit. This time we've got an extra loop. We've got one loop going around this way from the cell, and then the other loop goes round this way. So we've got two loops in this parallel circuit. We could have 3 loops, we could have infinite number of loops, but for now we have 2 loops. In a parallel circuit, when we add resistors, the total resistance goes down. You don't need to know any equations, just the fact that the number gets less. Current behaves differently in a parallel circuit, and it splits at a junction. So a junction is where there's a different path for the charge or the electrons to flow. So if we have 3 amps coming out of our battery, 1 amp may take this path, which then leaves 2 amps to go around the second loop. Where we have the red dot, we've got another junction. So this time 1 amp joins from there, 2 amps join there. So where they meet again, we have 3 amps, just like we started. Charge is conserved. It stays the same from the start to the end, but it might split depending on the path that it takes. Because there's only 1 amp here and 2 amps here, the lower the current, that suggests that the resistance here is higher, and it suggests that the resistance of this one is lower, so more of the current will flow through the easier path. But either way, starts at 3, ends at 3. When dealing with potential difference in a parallel circuit, the total potential difference from the power supply is still the same, but only in each loop. So reminder, there's one loop, and the second one is going around there. As an example, we've got 12 volts from our power supply, so in this first loop, it has to add up to 12. So I've just chosen 7 and 5. It gets split just like we saw in the last example. And then in the second loop, I've only got one resistor, so that receives all of the potential difference. So we start at 12, ends at 12. Thanks for watching.